Please can you remind me if you'll be so kind, staring out into space, asking God to hear my case, trying to think of all things past. How long will my memory last? The purple angel, purple angel, purple angel, you're next to me.
Well, welcome everyone to Alzheimer Speaks Radio. I'm the host and founder, Lori LeBay, and today we're going to have an exciting show, but as usual, I always like to give everybody a big shout out and kind of tell people a little bit about us before we get started, because we're always getting new listeners all around the world. And so for those of you that are new to our show, Alzheimer Speaks is an advocacy-based company providing multiple platforms to shift our dementia care culture from crisis to comfort around the world. And we truly believe that we're able to do that and have an impact thanks to each and every one of you. You see your likes, your clicks, and your shares have gotten us some amazing recognition, and we surely hadn't done that on our own. To be called, by Oprah as a health hero, and Maria Shriver as an architect of change, and Dr. Oz naming us the #1 influencer online. Again, that's because of you guys. And so I really, truly do believe we are a team in terms of shifting our care culture and getting information and such needed content in terms of products, services, and tools to the people who so desperately need them. So I want to thank each and every one of you. I also want to invite you to be a guest on our show, because we talk to everybody. We think that we can't shift our culture if we don't hear from everybody at all levels. So if you've got some symptoms right now, maybe you've been diagnosed, maybe you're a family member or a friend, maybe you're a business professional or a researcher like we have on today, musician, movie director, everything is a go here. So reach out to me at alzheimerspeaks.com and we can talk and see if we can raise your voice as well. Now, before starting, I always like to give a shout out to a few organizations, and there's a brand new one here in the U.S. that I'm super excited about, and it is the World Kindness USA organization. They are all over the globe, and the U.S. is just getting on track with this, and I think it's a absolutely perfect fit, because who can't use more kindness, especially in the world we're living in. So LA's actually done a soft launch a couple months ago, and we are going to be doing another launch in Maryland, and there's lots of different cities, school districts, workplaces getting involved with this. So if you're interested, go to worldkindnessusa.org and to become a member like I did. It's a pretty cool group of people, very positive and very uplifting. The other organization I want to mention is Maria Shriver. I so believe in her work, and she has an organization called the Women's Alzheimer's Movement. And every year she does what's called Move for Minds, which she does typically in June. But she's really interested in women's studies of dementia and what are the differences and why is it that more women than men seem to get dementia. So feel free to check her out. And with no further ado, I need to get to our guest here today. We are honored to have Russell M Leibovitz with us, and he leads the team at Amprion, and he has this vision which is really going to revolutionize how we diagnose Alzheimer's disease and Parkinson's and some other neurodegenerative diseases. His company is paving the way to reinvent drug development and discovery for these really elusive and incurable diseases that are affecting so many of us. Russ is the CEO and co-founder of Amprion, and he brings unique hands-on experience, that novel diagnostic, technologies that are out there through the FDA regulation process, which we know is always a difficult one to do. So welcome, Russ. How are you doing today?
Doing great, Lori. Thanks so much for having me on your show and, for continuing to do such great work that helps so many people.
Well, thank you. I think we're all in this together, and the more conversations we can have, the more progress we're going to make. And connect people again to those service products and tools that are so badly needed. Why don't we talk first, Russ, if you don't mind, but tell us what are some of the major challenges in developing an effective treatment for Alzheimer's disease?
There are a number. If you just think about in the last 40 years, we've revolutionized what we can do in cancer. And really, we've made no substantial progress in anything to offer patients with Alzheimer's. And, I think largely it's because we're just beginning to understand the causes of Alzheimer's and related neurodegenerative diseases. And we believe they're unique, and that because they're unique, they require different science and different approaches. So one of the biggest problems for Alzheimer's until recently was we don't have any really good predictive biomarkers for the disease. We don't have molecules that we can look at pretty simply in the blood, in the urine, and to be able to say who actually has the disease. So by the time we know who has Alzheimer's, unfortunately, it's usually too late. We find it late in the disease, and we'll talk about that a little more during this discussion. But so first, we don't know who has Alzheimer's until it's too late. We believe, just like in cancers and other complex diseases, there are probably many different molecular variants of the disease, and without good biomarkers, we don't know who has what type of Alzheimer's, and therefore as we develop drugs, as the enterprise as a whole develops new drugs, we need to be able to match the right drug to the right patient. And to do that, we need really effective biomarkers, and we need them earlier than the late stage of the disease. Biomarkers drive drug development, and there's no chance for an early diagnosis before permanent damage has occurred without some sort of a test to say, this person is on the path to Alzheimer's, this one isn't. This person may be getting Parkinson's disease, but at this stage, it's hard to tell the difference. We need good molecular biomarkers, and that's really what Amprion focuses on. Amprion has developed tests for what we believe are the earliest and most reliable markers to a number of neurodegenerative diseases. And basically, we focus right now on 3 different proteins that are normal proteins in the brain, but that under certain circumstances misfold into shapes that are toxic to the brain and kill nerve cells. And those 3 proteins, and we'll talk about it again, and they're reasonably well known in these diseases. One is called A-beta. A second is called tau, and both A-beta and tau appear to be involved in misfolding and the cause and progression of Alzheimer's. And then there's a third called synuclein, which plays a larger role in Parkinson's, but also can be the cause of some dementias. And this is really where Amprion's focus is very, very sensitively detecting these misfolded proteins at very low levels, ultimately prior to the appearance of symptoms, when we believe drugs, devices, exercises might really work.
Wow, that's amazing, because you're right. Most people, they're having symptoms. They're already well down the path by the time they get diagnosed. So if you can come up with those biomarkers to really take a bite out of that and let us get ahead of the curve, that's huge advantage for all of us in this process. So many people, though, are afraid of going in and getting tested, So how do we still encourage people to get tested earlier while you're working on this? What are your thoughts there?
Yeah, well, first, that's a great question, because every advance has a certain cost. And I'm not talking about dollar and cents cost. I'm talking about, a lot of people ask, do I want to know the answer before there's an effective cure? And we've got a number of answers. We thought about this a lot. And so what we'd say is, in the beginning, maybe not everyone needs to be tested early. But people who need to be tested early are those who feel themselves that they're at higher risk, and they want to know, and they want to be proactive. So people at higher risk of Alzheimer's might be those who know they have multiple family members who have had Alzheimer's, and they know how terrible it is. There are some known genetic risks. So people who, for whatever reason, get genetic testing and know that they have a genetic predisposition to this, it doesn't mean they're going to get the disease, but they might want to know, okay, I have a 3-fold or a 5-fold higher risk of getting the disease. Where am I on that spectrum? the other places where this might be very important is we have a lot of data now that suggests that the triggering of Alzheimer's and related dementias can come from a number of places. I said it can be genetic, but also there seems to be data that people who are exposed to multiple head injuries when they're young and in middle age, it can be through sports, through work, through the military. These people know that they have a greater risk, and they might want to know as well. And so, other places where it's important to know whether you have the disease or not are at the earliest stage of symptoms. It turns out that people who show up with their doctor's office, either they come in themselves or their family brings them because they think they're having memory problems or some sort of cognitive loss, only no more than 50% of those will go on to have Alzheimer's, somewhere between 30 and 50%. That means that, 50 to 70% of the people who show up really concerned and really anxious that I'm not remembering names as well, I don't do my job as well, I don't think as quickly. 50 to 70% of those people may not be on the path to Alzheimer's, and having a diagnosis here really can be life-changing. They don't have to worry about what's going to happen over the next 10 years. They don't have to worry about giving away assets or moving. So sometimes a negative diagnosis is just as useful. And then the final piece here that why someone might want to get an early diagnosis is that even before there are effective drugs, there seem to be a lot of people who believe that lifestyle changes could have a benefit here. So if you know that you're very early, you don't have symptoms, or I know that I'm very early and I don't have symptoms yet, then I'm going to try certain things that different lifestyles. Some people have data that a Mediterranean diet, when adhered to very strictly, seems to at least slow down the disease. And the goal here is that we want to slow down this progression. If something takes 20 or 30 years from the time of first diagnosis to actually have symptoms, if we could slow it down even 5% or 10%, we would be very happy if we slowed it down to where people get it at 120 rather than at 70. That's a giant advance. So overall, the reasons for getting early diagnosis are the ones we've gone through. Some people are at higher risk. Some people might want to try lifestyle changes. And then finally, how are we going to develop drugs that are effective if people aren't willing to be tested early to be in those clinical trials? So, there are trials going on all the time, and the drug companies clearly feel that they want people who have the earliest possible diagnosis. So it's good for the individual. It's also good for everyone else. If you care about the community at large, knowing where you stand and possibly enrolling in a clinical trial is something that a lot of people would want to participate in. So early diagnosis helps with all of those. I hope that answers your question.
No, I think that was really thorough. And I hear all the time about clinical trials. People are just groveling for people to get in because they can't push, these treatments forward without this baseline. And so it really is critical for us to join forces together and be part of that and try to take some of the scary out of it. And I'm glad that you mentioned that, genetics don't always mean for sure we're going to get something. Our genes aren't always our destiny. But again, it's an odds game. And, that's what you're looking at. And then being able to talk about lifestyle changes, if it's exercise, if it's diet, if it's sleep patterns, if it's hydration, there's all different types of things. It's very important, I think, for us to be more conscious of that. And I would throw in a fourth reason for people to get diagnosed is I think we need to have more conversation about it, because we're not going to get the help we need if we're not talking about it. And so people have to get involved in this conversation. And just even in the last, I'd say 5 years, we've made huge progress about the conversation, and we're seeing dementia-friendly communities develop, and we're seeing some government get behind it. Again, we still don't have near the funding that we would like to have, but we have to kind of still pat ourselves on the back and say, we're a lot better than we were 5 years ago. And there's a lot further we can go. But again, if we don't talk about it, if we don't have a conversation, if we're not honest about what the needs are and what the findings are, we're not going to be able to progress. So I think those were all really, really key points. One of the things, and I had mentioned this even with Maria Shriver, is really wanting to investigate, men versus women, because it seems like more women get dementia than men. But, some people say, well, we live longer. And what are your thoughts on that whole basis on how Alzheimer's disease or other dementias impact us?
Sure. Thanks. That's another really great question. And, I'll answer it based on some recent findings in the literature that are fascinating, a little scary, and that point out even more the really urgent need for early diagnosis. Looks like there are differences between men and women in not only how they get the disease, but how that disease manifests itself. And what I mean by that is that at various stages of the disease. So right now, there's some very expensive imaging that one can do to look in the brain of people who are along the path to Alzheimer's. It's mostly done in an academic setting because it's so expensive and requires injection of radioactive tracers. But what you can see is that at most stages of the disease, women and men at the same stage with respect to the imaging and the extent of the disease on a molecular level, the amount of plaque they have, the amount of A-beta deposited in plaque, at almost every stage for the same amount of plaque, women have much worse symptoms. So it's not clear why, but women are much more at risk and need early diagnosis much more than men, that the same burden of plaque in the brain seems to have much more severe consequences for women. So we can't allow any longer, this late diagnosis, especially for women. It's really critical. And no one knows all of the reasons for this right now, but this is really sort of hot off the press data, and it seems to be confirmed in several different groups and several different studies. So women are going to need earlier diagnosis and more aggressive early treatment compared with men. And we wouldn't have known this unless we've done these studies. And in all fairness, historically, a lot of research, clinical research, too much has been done only on men and not enough on women. And now through federal mandates and just the recognition that what you find in men is not necessarily true in women, we're now starting to get this really great data that I think can impact everyone in a much more positive way.
That is fantastic. I was not aware of that latest data there. And, they always say men are from Mars and women are from Venus, and our brains work different. And do you think that the way we process things could have an effect on it, or is it just too new to really know?
Well, I don't know that there's data at this point. The data says that for the same amount of misfolded protein, remember we said that what Amprion does is to measure misfolded A-beta and tau in Alzheimer's patients. So with the same amount of misfolded A-beta and tau between men and women, women seem to have much worse symptoms. And, there are fundamental differences in the brain, the way the brain works. Since so much of Alzheimer's is disrupted connections in the brain, the way we link memories. It could be linked to a fundamental way that we structure information, or it could just be that, in many cases, their hormones, the estrogens and things are protective. In this case, they may be anti-protective. So we don't understand the physiology yet, but the data is very important, and it just points us in the right direction about how we have to treat this. And certainly, I believe there'll be a lot of work moving forward to try to understand if these differences are hormonal or they have to do with X or Y chromosomes. So I look forward to learning. But right now, we are really focused at Amprion on early diagnosis, and this data between men and women really points to the fact that, we need to accelerate what we're doing and get this out to women first and then to men.
So when it comes for people to be part of, I don't know if you have clinical trials or if there's tests that can be done now in the doctor's office that can sort this out, how does that whole process work?
Well, yeah, we do things right now on a research basis because, getting something approved by regulatory agencies as a test, you have to be able to run it literally 1,000,000 times a year and have it give always the right answer. So, you know, there's a lot of research on what we're doing and what other people are doing that in a study of 100 people, you get great results. It's really the ability to scale these tests so that it's done 1,000,000 or 10,000,000 times a year, and you're sure you always get the same answer no matter where it's done and who's doing it. So we're moving as fast as we can, but we really respect the regulatory process. If you roll things out too quickly with something new, you know, sometimes, well, most of the time, an incorrect answer is worse than no answer at all. So right now, on a research basis in small, very controlled studies, we're getting great data. And our goal is to, using robots, by improving chemistry, to get this to the level where we can do this 10,000,000 times or more a year and give absolutely rock solid answers.
Okay, great. Now, if people wanted to get involved with your trials, are they located just in a certain sector in the U.S., or do you have pilots around in different areas?
Yeah, we work generally with large academic centers that really run the studies, and our test is part of this. You know, the best studies will look at a number of different factors. They can look at imaging, they'll look at clinical diagnosis, they'll look at cognitive abilities, and then they'll look at markers like ours. So, you know, I think that if one starts to look for clinical trials that are emerging here, one, if it's okay to say, you know, we're trying to reach out to a community in parallel on our website, but we're happy to work through you. But ours is Amprion, AMPRION-ME, Amprion Me as it relates to me.com. And so we give updates all of the time. And, you know, as we know of studies or as we're conducting studies, we want the community that's interested to be a part of that. And we love to work with groups such as yours, Lori, that really reach out to, you know, everyone who's doing great work in this area. So sure, we're reachable, and you know, through you and others and through our website, we intend to keep people apprised and to answer as many questions as we can that arise about this.
Okay, great. Now, in your introduction, I also mentioned you were doing some work with Parkinson's disease. Would it be okay to talk about that?
Sure, if it's okay with you. One of the things that we and a number of others have discovered over the last 10 years or so is that neurodegenerative diseases, these slow, progressive diseases that really just rot our brains from within, Alzheimer's, Parkinson's, there are a number of other diseases that have symptoms in between. So Parkinson's being thought of as a major, predominantly a motor disease, and Alzheimer's being thought of predominantly as a cognitive disease. It turns out that Parkinson's can have dementia, and that there are other diseases that have some motor or some dementia aspects. They're all very closely related. And interestingly, you know, we and a number of others now believe that all of these are related to a disease that we all thought about 20 years ago and that sort of came and went, which was mad cow disease. And what was interesting about mad cow disease was that it also rotted the brain from within. But the important thing was that the way the disease replicates throughout the brain was a whole new mechanism of disease that no one had ever discovered or thought of before. And it's a protein misfolding disease, meaning we make all sorts of proteins, they do their function in the brain and elsewhere, and then when they're done, they're destroyed and in an orderly fashion removed from the body. Well, it turns out that under certain circumstances, normal proteins can misfold into shapes and particles that, one, are toxic and now are hurting the brain. And even more importantly, these misfolded protein particles can replicate on their own in the brain, just like a virus. And so that's, you know, mad cow disease came about because of one had an exposure, a very high exposure to contaminated materials, and that it could get into the brain and replicate. And so the same mechanism, which is these misfolded proteins were referred to as prions, and in fact 2 Nobel Prizes have been given so far for prion diseases. And in the past decade, it's become clear that a number of proteins can misfold this way, and that Alzheimer's is the result of 2 different proteins in the brain misfolding this way and replicating on their own, and that's how it spreads. And those 2 proteins are A beta and tau. And Parkinson's seems to operate by a similar mechanism, but with a different protein called alpha-synuclein. And so at Amprion, we really focus on all 3 of these proteins. Turns out that if there's A beta, tau, and synuclein, A beta and tau are the hallmarks of classical Alzheimer's, but one can find that with tau alone, when it misfolds, there are a number of dementias and motor diseases. Synuclein by itself gives a disease, and there's no reason to think that we're not going to find people now that we have these tools that have synuclein plus A beta and synuclein plus tau. And this is what I referred to earlier when I said there are going to be different variants of these diseases. These are much more complex diseases than we thought, and successful treatment may require, just like in cancer, combination therapies. It's very rare in cancer now to get one drug. In Alzheimer's and Parkinson's, we're probably going to need multiple drugs. The problem is we don't have our first yet. So we need to get our first before we can have a combination. So Parkinson's is very similar. It's another misfolded protein, and it predominantly just affects a different part of the brain. But does that answer your question, or do you want to talk about it more?
No, that was very helpful. And I see so many people who have dual diagnosis, or things merge. They start out with Parkinson's, and then all of a sudden the dementia is added, or vice versa. And yet on the communities like in Facebook and things like that, I hear from a lot of people living with dual diagnosis that the doctors don't seem to understand the combination between the 2. And so, anything we can do to push that forward, I think is greatly helpful. And I think gives them a little bit more peace of mind too, because it's hard when you think you have one thing and then all of a sudden it's like, oh, maybe not. Maybe it's this instead. And there's a lot of that going on, because in a lot of ways, this is a baby disease, because even though they've been around for 100 years or so, we don't know much about them. And we've got a long ways to go with that. Now, when it comes to genetics playing a role, I guess, can you talk a little bit, we talked a little bit about Alzheimer's and genetics, but can you talk about Parkinson's, and is there a genetic factor there too?
Sure. So let's talk about them together as to how genetics might impact these diseases, all of them. What we see is that if these diseases are ultimately caused, there's something that happens in the brain, or in the case of Parkinson's, some people believe even outside of the brain with gut in your bacteria, something happens that leads to these proteins in the brain misfolding into these self-replicating particles. And again, that something that initiates it could be repeated head injuries. It could be something that happens in the gut. It could be having an infection, having encephalitis, but something happens that gets this process going. Once it gets going, then, then the genetics sort of determines in each person how this process plays out. So if you have a mutation or a genetic variant that causes proteins to misfold once it started more readily, then the disease will progress more readily. And in fact, there are in Alzheimer's, there's a normal gene variant called ApoE4 that you probably know a lot about. It encodes a lipid binding protein everywhere in the body. But ApoE4 seems to interact with the misfolded proteins with both the A beta and the tau, and it probably accelerates their misfolding. It probably takes these misfolded proteins and increases their toxicity to neurons in the brain. And then on the other hand, at the same time, it may block the clearance of the misfolded protein. But ApoE4 accelerates the effect of A beta and tau misfolding. But then on the other hand, ApoE4 is not a sentence that you will get the disease, it just accelerates it. For Parkinson's, there are genes as well. One of the ones that's been looked at most recently is called LRRK2, and LRRK2 seems to play multiple roles in the misfolding of synuclein. One is that it also seems to play a significant role in slowing down the normal clearance of these misfolded proteins. So, genetically, if we have something that causes the proteins to misfold more, if we have something that makes them more toxic to neurons once they're misfolded, or a genetic locus that just reduces the clearance, the normal protective mechanisms that get these misfolded proteins out of the brain, any one of those pathways can play a role. And we do have genetic variants both in Parkinson's and in Alzheimer's that hit all of these pathways. And there's a lot of work going on to try to find drugs that would, for example, enhance the clearance of misfolded proteins or reduce their ability to misfold in the first place.
Interesting. It just seems like there's so many different angles of research going on right now in terms of, what's the cause, what's the root cause. But I would imagine that that's pretty typical with any disease. There's little soldiers marching to all different types of theories out there trying to break through. What gives you such great hope and promise about, your technology that you're working on?
Sure. Well, what we work on really looks at these misfolded protein particles, these also referred to as prions or prion-like particles that probably underlie a whole group of diseases that haven't been able to be studied before. And by now having tools, you're actually looking at the part of the disease that spreads from cell to cell and replicates. By being able to track that, we should be able to fine-tune which drugs are affecting that, to look early, but also to be able to look at the interaction between all of these misfolded protein particles. As I said, the secret to beginning to beat cancer is understanding that there are multiple mechanisms leading to breast cancer. There's probably not one breast cancer. And so by having diagnostics in breast cancer that allow us to see what gene mutations every individual has, we're getting better at tailoring treatments. We need to be able to do this for neurodegenerative diseases. In other words, there probably isn't one dementia, there may be 20 dementias, and when we understand what the molecules are, what's replicating, how it's spreading from cell to cell, then we can begin to effectively treat each person with it becomes personalized medicine for neurodegenerative disease. And that's really what we need. That's what's working in cancer. And I look at neurodegenerative disease as a different mechanism, but it's a similarly complex disease. So I'm optimistic. The caveat here is, our war on cancer really started in 1971 or 1972 when the federal government just said, all right, we're going to put an inordinate amount of resources behind this. And it took 40 years. Now, in neurodegenerative disease, we can't wait 40 years. But just this year, the Congress is now coming to the realization that this is the next frontier that we have to conquer to give us all long-term health and prolong our lives. So if in 2018 or 2019 we suddenly have the equivalent of the war on cancer, which was in 1972, the difference is we have to learn from what they've done. We've got to jump over, we have got to bridge to getting this done much faster. We can't wait 40 years. So in the next 10 years, we're going to have to do what they did in 40 years.
That's really true with the numbers that are being affected. And we're hearing more even children getting diagnosed with this disease, and yet nobody can really put their finger on what's causing it. And is it our cell phones? Is it our food? Is it our whatever? There's so many different variables because lifestyles have changed so drastically. I'm going to be 60 here in another year, and
never would have guessed. So that's great.
And I can't believe how much things have changed. It's unbelievable. And And so just kudos to you guys for stepping out and going after and trying to tackle this. Is there anything else that you would like our audience to know about your company or your process?
Sure. I mean, I think what's important here is to realize that what we work on is a fundamentally new mechanism of disease. It's as important as understanding the ability to track mutations in cancer cells or to identify viruses as the cause of HIV and related diseases. And so, we believe that these misfolded proteins that can self-replicate are probably going to play a role in a number of diseases that have been unsolved to this time. So clearly in neurodegenerative diseases, but my co-founder at Amprion, Claudio Soto at the University of Texas, is starting to collect data that indicate that in a certain number of people with diseases that you wouldn't have thought were related to prions and misfolded proteins, like type 2 diabetes. Some of the symptoms, some of the patients have misfolded proteins near the islets in the pancreas. And so there are a number of problems that we have not been able to solve, and not all of them, but a significant number of them may be due to this new mechanism. And at Amprion, we can look at any misfolded protein because we amplify them. We can detect almost a single particle, certainly 10 to 100 of these particles. And so, we can start to provide insights into diseases that no one would have guessed were caused by misfolded protein. So I think it's a new frontier for a number of diseases that have been very difficult to make inroads for the last 50 or 100 years.
So just to be clear, what you're working on for our audience is it's not a new drug. You're trying to figure out what's causing it first.
Right.
You can go tackle it, which to me just makes so much sense, where sometimes when I'm talking with researchers, they'll say, well, we're still not sure what causes it, but we're pushing this. But you guys are really going after, this is what we think it is, and we need more information, so we need more people to get involved with this to be able to track and gather data. Is that correct?
Well, so we're doing basic research to understand these diseases. At the same time, we're developing tests that we want to offer to the public as quickly as possible so people can assess where they are on the spectrum if they're at risk. And then finally, we're working with between 6 and 10 drug companies who are actively developing drugs for Alzheimer's and Parkinson's. And what we can do is to, one, again, as we said in the beginning, if we can match patients. So there's no sense if you have a drug against misfolded alpha-synuclein in Parkinson's, there's no sense putting a patient in your clinical trial who doesn't seem to have misfolded alpha-synuclein. Same in Alzheimer's. We found that in some Alzheimer's studies, we can't detect misfolded A beta in 30% of them. It doesn't mean they don't have a dementia, but in 30%, it may not be caused by misfolded A beta, and a drug against misfolded A beta probably isn't going to help that patient. And so by matching patients with drugs, we might help these drug companies increase their success from 40 or 50% to 70 or 80%. And that's what the FDA needs to allow new drugs to come into the market. And that's what all of us need in order to have 5 or 10 drugs to hit these things rather than none, which is what we have right now.
Now, they can go to your site, which is www.amprion and then me for me.com. And you also have some videos on there that I think are really, really well done that kind of explain what you're doing and who you are and why you're doing things. So I would encourage people to go and look for that. And you can also sign up for a newsletter and get involved. Also, I'm going to add a contact there through the website that people can reach out to you for further information if they so like.
And thank you, Lauren. We also have a very active group and presence on Facebook of people who are interested in this. And we are so interested in continuing to work with you. You reach out to all of the communities. We are one of your constituencies, and we really believe in what you're doing. And, we feel that, we're happy to be on your team.
Wonderful. I'm glad to have you join us. So for Facebook, do you know what the name is? It just Amprion?
Amprion, Amprion.
I'll ask one more time. Is there anything else that you'd like to share?
I think I've given a lot of information today on what we're doing, and we're just part of a big enterprise. So happy to be on the same team.
Well, great. Well, thank you. And I appreciate you, talking kind of street smarts to us and not too much medical terms so that my audience and myself can digest it. Because sometimes I'll get researchers on and they're just talking up here and the rest of us are going, okay, what does that really mean? What does that really mean to you and I on the street? And so I so appreciate your ability to be able to do that and communicate well. So thank you.
Thank you, Lori.
In wrapping up here, I'm just going to give a shout out to a couple other organizations. If you are dealing with a form of dementia and would like to be part of a memory cafe, you're going to want to go to memorycafedirectory.com. That's memorycafedirectory.com. That is a resource directory. We're now over 500 cafes in the U.S., which is pretty exciting. And that is put together by Calendar Cards, and Calendar and Cards both starts with a K. And they have a memory system to help people continue to live independent lives. I would also like to give a shout out to the Alzheimer's Research and Prevention Foundation, who focuses on dealing with dementia more in a holistic fashion. So they have great resources on diet, exercise, and a wonderful meditation program that you might be interested as well. And then last, I'm going to shout out to Dementia Raw with Kathy and Tammy. I just went through their certified dementia communication specialist training that they held here in Minnesota. It was absolutely fabulous. It's 2 days. I highly recommend it. They call it introspective improv, and it was just really a lot of fun and very engaging, and gave all of us, I guess, new ways to engage. Again, thank you so much, Russ, with Amprion, to be on the show today. You gave us some wonderful information. And again, you'll find the links to the company in the resource page on the radio show, as well as on the blog and on YouTube. So thank you so much. Bye now.